The rule for taking derivative of an exponential function is quite simple. The derivative of, with respect to t of e to the t, is just e to the t. Now there's another way to write e to the t that is a little more compatible with the chain rule, as usually expressed, and we'll talk more about this next time. But we could write e to the t as exp of t. And if you write it as exp of t, it becomes clearer what the two composite functions are that make up a function you're trying to take the derivative of. Now, everybody was okay with the idea that derivative with respect to t of e to the negative 5t is negative 5e to the negative 5t. And this is by the chain rule, because this is a composite. It's the exponential of negative 5t. The inner function is negative 5t. You take the derivative of that, you get negative 5. And then you multiply that by your e to the negative 5t because of the rule for the derivative of the exponential function. Now we'll do a lot more with this next time, but in the homework I ask you to do a few fairly basic problems. So writing this out in the exp notation, I say derivative with respect to t of exp of negative 5t is the derivative with respect to t of negative 5t times exp of negative 5t. The argument of the exponential function, or the exponent you have if you do the e to the exponent notation, isn't going to change because of this rule. The exponent here doesn't change. But if you have anything but just a t here, you're likely to have need to apply the chain rule, and you're going to get something like this. So another example, derivative of exp of t squared. Well, that's the derivative of the inner function, the t squared function, times exp of t squared. Okay? And derivative with respect to t of t squared we know is 2t. So you're going to get 2t exp of t squared, but I wrote that out now, e to the t squared. So now, we want to talk about antiderivatives and actually motivate some of the tricks that we're going to have to play to calculate antiderivatives. Antiderivative of exp of 2t is what? Well, we know from this rule that the exponent isn't going to change, but something is. So let's just see what happens. Well, since the exponent doesn't change here, your antiderivative is going to be some multiple of the exp of 2t, because you're still going to have an exp of 2t when you're done. Okay, so let's just look. The derivative of exp of 2t is what? Well, we see, as we saw down here, that that's going to be 2 times exp of 2t. The derivative of the 2t, which is 2, times exp of 2t. Well, it follows then that the derivative of, and what we want is, now we want a function whose derivative is equal to just exp of 2t. Well, if the derivative of this is 2 exp to the 2t, then to get just exp of 2t, we take the derivative of half of this. So the derivative of half exp of 2t, just to check it out, is 1/2 of 2 exp of 2t, because the derivative of exp of 2t is 2 exp of 2t. And half of 2 is 1, so that's exp of 2t. Antiderivative of exp of 2t then is 1/2 exp of 2t. And if you think about it, you can see how the chain rule is kind of used backwards to figure this out, because the derivative of this would be 2 times this. Antiderivative of this, well, if the derivative of this is 2 times this, then if you take half of this, the derivative will just be this. Now, you have to think about that. You're not going to understand that just by listening to me say it. An antiderivative of t exp of t squared, and that's not a square. That was a question mark, but I'm going to erase the question mark because that looked pretty confusing to me. How are we going to get that? Well, I wouldn't throw that at you out of the blue, but since we already did this, there's a hint. So if we look at this, we see that the derivative of exp of t squared is going to be 2t times exp of t squared, or as I wrote it, 2te to the t squared. Okay, we can use that fact because the derivative of exp of t squared then is 2t exp of t squared. And that's a whole lot like t exp of t squared. It differs only by a constant factor. This tells us that if we took the derivative of half of this, we get this. So, 1/2 exp of t squared is the antiderivative of t exp of t squared. Now, you can't always see how the chain rule is used backwards to get something. It can get very confusing. So we have tricks and methods. Tricks like what we call U substitution, what's often called U substitution, and what's always called integration by parts. And these are integration techniques that we're going to use. So we need to practice derivatives of exponential functions. And then we need to develop rules for finding antiderivatives of exponential functions. Not rules, but techniques. Another thing I'll say, just in closing, if you wanted an antiderivative of e to the t squared, you would be out of luck. You can't write down an antiderivative for e to the t squared. Impossible. Never happened. We'll see all that as we move a little more methodically through chapters 4 and 5.